Check it.
Okay, welcome back. Today we're going to be talking about completing the square as an alternative to factoring when you're solving equations. Now, I have a warm-up here. I'm going to try to solve this by factoring using the methods that we just learned. This looks like a candidate for reversed FOIL. So you put down your parentheses and you put down your x for each set of parentheses. Now you ask yourself, what factors of negative 14 add together to give you negative 2? Do any of these add or subtract to give you a quantity of 2? Well, no. There are no two numbers that would add together to give you negative 2 that would also multiply to give you negative 14. So this is not factorable. So some things aren't factorable. Some things cannot be solved by factoring. So what do? We have a few options here. Now, if you have an equation that only has a squared x, no unsquared x, meaning a quadratic x only, no linear x, right? There's no x here, for instance, right? Just a squared x. Well, then you can use what's called the square root property, and we're going to do that first. And basically, you're going to solve it algebra 1 style. You're going to get the x squared by itself. So we'll subtract 10 from both sides here, and we get 2x squared equals 50. Then we'll divide both sides by 2, and we'll get x squared equals 25. And there you go. That's algebra 1 style, but we're not done because it's still x squared and not x. So you might say, all right, well, I'll just square root both sides. And you can do that. That's what we're doing today, the square root prop. And a square root does, in fact, cancel out a square. So this cancels out this. This is not x. This is wrong. Because when you square root an x squared, you actually don't get x. You get the absolute value of x, like that. So this absolute value part here is a part that's overlooked by a lot of people, including teachers. So what about this side here, the square root of 25? Well, a lot of people think when you take the square root of something, you get plus or minus 5. That's wrong. So then what do? Well, this is now an absolute value situation, and you're supposed to t-bar. And that's where you get the plus or minus. So yeah, the answer is x equals plus or minus 5, but people get there thinking that it's because this is true, that this equals plus or minus 5, and this is totally false. Anyway, that was solvable. How about this one here? Well, we'll blast through this really quickly. We're going to subtract 10 from both sides, so we get 2x equals 46. We'll divide both sides by 2. We'll get x squared equals 23. And now we're going to square root both sides. And once again, what is the square root of x squared? It's not x, it's absolute value of x. And what's the square root of 23? Well, 23 is a prime number, and it's not a perfect square. So if you try to square root it, you're going to get an irrational number, which is one of those decimals that goes on forever and never repeats. It's like pi, 3.14159, blah, 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 just goes on forever. So we don't want that. We don't want to try to, because then what you're going to do is try to round it off, and that's going to make it inaccurate. So we're going to leave it as just radical 23. And then when we drop the bars, that creates the plus or minus. But the plus or minus does not come from the square root, it comes from the absolute value bars. So there you go. You do have two answers. X equals the square root of 23, okay? And x equals negative the square root of 23. How about this next one here? You have something in parentheses, a binomial that's being squared equal to 17. Even though there are two things in here, you can square root both sides. So you can square root this side here, and you can square root this side here. Now, 17 is a prime number, meaning you can't really break it down, and it's not a perfect square. So we're just going to leave this as square root of 17. Notice there's no plus or minus when we do that. On this side, however, when the square root cancels out the square, this creates an absolute value around the x plus 4. When you drop the bars, this becomes x plus 4, and dropping the bars creates a plus or minus on the other side because of the t-barring. So it's an implied t-bar, so to speak. And then subtract 4 from both sides, and you get negative 4 plus or minus 17, and you can box that. Understand that is two answers. That's negative 4 plus and negative 4 minus the square root of 17. Those two different answers. Let's go to this example right here. Okay, the first one. Is this trinomial the square of a binomial? And the answer is, yeah, it is. It's actually x plus 4 times x plus 4. And I'll show you, I'll prove it to you. X times x is x squared. X times 4 is 4x. 4 times x is another 4x. And 4 times 4 is 16. And when you combine like terms, you get x squared plus 8x plus 16, which is right here. So this, I've just proven to you, this trinomial is equal to a binomial times itself, or you can just write it as x plus 4 squared. So this is a perfect square of x plus 4. Okay, just like 25 is a perfect square of 5 and 36 is a perfect square of 6. X squared plus 8x plus 16 is the perfect square of x plus 4. Now, I kind of knew ahead of time that it was x plus 4, but how would you know this if you didn't have the answer ahead of time? Here's how you know. You look at the middle number. Whatever this middle number is, cut it in half. So this is in standard form. This is an ax squared plus bx plus c. Take the b and divide it by 2. What do you get? Well, b is 8, divided by 2, you get 4. Then square it. So take the b, divide it by 2, and then take that and square it. And that should give you your c. If it does, then this is a perfect square trinomial. So if you cut the 8 in half and square it, you cut the 8 in half, you get 4, you square it, you get 16. Yeah, that's the right relationship. This is a perfect square trinomial. So now you know that this has to be the square of x, obviously, because your first thing is going to be x times x. And then the question is, what is the number over here? Well, the number over here is whatever the square root of this is. So that's 4, okay? And everything is positive, so it's a plus. So this is x plus 4 squared. How about the second one here? X squared plus 10x plus 50. Is this a perfect square trinomial or not? Can this be written as something plus or minus something squared? Okay, that's the question. So let's see. Take the middle number, the b, and divide it by 2. You get 5, right? Now square that 5. You get what? 25. Is that the number sitting here? No. So this is not a perfect square trinomial. It's not a PST. So there's no way to write this as, x plus, some number over here squared. Okay, how about this last one? Last example here. We have x minus 20x x squared minus 20x plus 100. Is that a perfect square trinomial? Well, look at the middle number. What's half of the middle number? It's negative 20, so half of that is negative 10. Then square that negative 10, which is what's there. So yes, this is a perfect square trinomial, and it is the square of what? Well, just look at the first and look at the last. The first is x squared, so the square root of that, the thing you would square to get x squared is x squared, And what would you square to get 100? It'd be 10. But here's the thing, there's a negative here. So that's going to be the sign that goes here. There you go. Now, if you want to check that, you can always go x minus 10 times itself. So there you go. Perfect square trinomials, how to spot them, and how to factor them. Okay, so why did we learn that? Because now we're going to use this idea of a perfect square trinomial to solve equations that we couldn't solve before. So take a look at this. Is this a perfect square trinomial? Take the middle number. If you square half of this, do you get this? Yeah, you do. So this is a perfect square trinomial. Since this is a perfect square trinomial, what is it the square of? It's got to be something and something squared. Well, this gives you x. And what do you square to get 9? 3. And what's the sign right over here? Plus. And there you go. This is the same as writing this. And now you got 36 over here. And now this looks like one of the problems we did earlier, where we just square rooted both sides using the square root property. So what happens? This kills this, right? The square root kills the square. And now you just have x plus 3 here. There is an absolute value bar here, right? And what is this? This is 6. When you drop the bars, this becomes plus or minus 6. And now finally, to get the x by itself, you subtract 3 from both sides, and you get negative 3, plus or minus 6. And those are two answers that you can actually flush out now. Negative 3 plus 6, and negative 3 minus 6. And that's going to be 6 minus 3 is 3, and it's going to be negative 9. Okay, let's try another one. So we have another equation here, and we see that the left side here looks like it might be a perfect square trinomial. Well, let's check. The middle number is negative 10. Cut negative 10 in half, you get negative 5. Square the negative 5, you do get positive 25. So this is a perfect square trinomial. What is it the perfect square of? Well, it's got to be something in parentheses with a square outside. That's the whole point. This is the square of x, and this 25 is the square of 5. And whatever the sign here is, that's what you're going to put here. And now this side is 27. So by recognizing that this is a perfect square trinomial, this is actually x minus 5 times x minus 5 equals 27. That's what this is. But since this is not a 0, you can't use a zero product rule, so we're going to use the square root property, which is when we square root both sides. Now, the square root of 27 can actually be simplified in a different way, but we'll learn that in a future section. For now, we're just going to leave this as the square root of 27 because it's a decimal, and we don't want to get any decimals at all. So we'll leave radical 27 as is. Now, what happens on this side? The square root and the square cancel out, and you get x minus 5 in absolute value bars. Don't forget the absolute value bars. The next step, you drop the absolute value bars, and that creates a plus or minus on the other side of the equation without t-barring. And now finally, you want to get the x by itself. We'll add 5 to both sides, and we get 5 plus or minus the square root of 27. So this is two answers here, 5 plus the square root of 27 and 5 minus the square root of 27. But it's an exact answer. They're both exact answers. There's no decimals, there's no rounding, there's no problems. Later on, we'll learn how to simplify this a little bit more, but like I said, that's coming up in a future lesson. So now we understand how to use the square root property, and we know how to spot a perfect square trinomial. Well, now we're going to bring in the main point of this lesson, completing the square. Because sometimes you have something that is not quite a perfect square trinomial, but completing the square will make it a perfect square trinomial. And then from there, you can do what we just did. So let's take a look. Let's say we have, these are some of the notes here. Let's say we have an equation like this. And this is not a perfect square trinomial. How do I know? Simple. Take the middle number. It's 10. Divide it by 2. It's 5. Square the 5. It's 25. Do I have a 25 here? No. So this is not a perfect square trinomial. So what do? Well, we'll start off by copying the problem here. Now, here's the thing. In order for this to be a perfect square trinomial, this has to be a 25, right? It has to be this thing divided by 2 and then squared. So this is supposed to be a positive 25, but it's a negative 11. So here's what we do. We get rid of this number, create an empty space like that, and then we put the 25 here, and then it's a perfect square trinomial. Now I've just violated like 4 rules of algebra by doing what I just did. So let's back up a second and talk about how we're going to get rid of the 11. Well, the only way to get rid of an 11, legally, is to add it to both sides. That negative 11 will cancel out, right? So now we have x squared plus 10x. We're going to leave a gap here because we're going to use it later. And now there's an 11 on this side. Now the question is, what goes in the gap here? Okay? And this is the part where we complete the square. That's what this is called, completing the square. We take this middle number, we cut it in half and square it, we get 25. So we want a 25 here, a positive 25, by the way. Since you're squaring something, it's always going to be positive. So we're going to add 25 right there. However, you can't add 25 to one side of an equation without also adding it to this side of the equation as well. Now you have a perfect square trinomial here. Half of this squared equals that. We're good to go. Oh, and by the way, there has to be nothing in front of the x here. This has to be a 1. So now that it's done, we completed the square on the left side here. This becomes x plus 5, the quantity squared. You can see that squaring the x gives you this, squaring the 5 gives you this, and half of this squared gives you that, so everything is correct. 11 plus 25 on this side, this becomes 36. And now we have something that we know how to solve from the earlier problems in this lesson. We can just take the square root of both sides and use the square root property. This becomes absolute value of x plus 5. This becomes 6. Drop the bars. Let's do that over here. Drop the bars. And that makes this a plus or minus 6 on this side. Subtract 5 from both sides. You get negative 5, right? Because when you do this right here, you get negative 5 plus or minus 6. And now that, since it's just regular numbers, you can split this and get 2 separate answers. Negative 5 plus 6 is 1. Negative 5 minus 6 is negative 11. And those are your 2 answers, and you're going to box your final answer there. But remember the absolute value bars here. This is something that you don't see in the textbook until much later in the textbook. And you probably didn't see in Algebra 1. So make sure that you understand that. Okay, let's try another one. So this problem is not written in any particular order here. So let's rearrange it a little bit. Now normally, you can't solve an equation unless there's a 0 on the end here. So let's actually start by doing that. The x squared should be first. The 8x should be second. So I'm going to rewrite this as x squared minus 8x equals 49. And then what I can do, well, yeah, if I want to get the 0 on this side, I can subtract 49 from both sides and get x squared minus 8x minus 49 equals 0. And then, I would try to factor it. This is what you would normally try to do first. Unfortunately, there are no factors that will work here. This is not factorable. Factors of 49 are 49 times 1, 7 times 7? I think that's pretty much it. No combination of numbers here will give you an 8. All right, so we can't use factoring. Is this a perfect square trinomial? If you cut this in half, you get a 4, negative 4. If you square the negative 4, you get positive 16. So this needs to be a positive 16 for this to be a perfect square trinomial. That's not the case. So let's go through the steps again of completing the square. The first thing you do is make some room here by getting rid of this. So add 49 to both sides. There we go. There's the gap. And here's the 49 again. So I know we're kind of back to where we were here. But here's the thing. We have this gap here. What do we put in the gap? Once again, take this, cut it in half and square it. You get positive 16. So you're going to put a plus 16 here. And by the way, this number is always positive because even though this is a negative 4, when you cut this in half, you get negative 4. Negative 4 squared is positive 16. So if I add 16 to this side to make this a perfect square trinomial, which it is now, I also have to add 16 to this side to keep the equation balanced. So now what is this the square of? This is a perfect square trinomial now. What is this the square of? Well, this is going to be the square of x because this is always just x squared. There's no numbers in front of it. And this is whatever you would square to get 16, which is 4. And whatever this symbol is here, where there's a plus or a minus, is what goes here. Now on this side, we have 49 plus 16, which is 65. And now we can square root both sides and use the square root property. So this and that, this square root cancels out the square. We get x minus 4 rather in absolute value bars. And this side, well, we can simplify this without getting decimals, but once again, we haven't learned it yet, so we'll just leave this as the square root of 65 for now. It's not a square root of 64 would have been 8. This is 8 point something, but we don't want to use any decimals here. Then we drop the bars. We get x minus 4 equals the square root of 65. Then we add 4 to both sides because this is a minus 4. And we get 4 plus or minus, oops, forgot the plus or minus here, radical 65. So there you go. That's your answer using completing the square. Now this is something that you couldn't have solved with factoring. And you definitely can't solve just algebra 1 style by getting x by itself. You could solve this one other way, which we're going to learn pretty soon. It's called the quadratic formula. So either completing the square or quadratic formula is the way to go when you have what's called an irrational answer, which is what this is. Okay, this last section here is going to be taking a parabola that's written in standard form, which is what we have over here, and writing it in vertex form, which is what is written here. Now, we learned about vertex form when we did parent functions and transformations. We learned that the h was the horizontal shift and the k was the vertical shift. And what's great about writing a parabola in this form is, like I said, you can tell what the vertex is, h comma k, and what the horizontal and vertical shifts are really easily. Whereas when they're written this way, you really can't tell where the parabola is without making a table. So here we have a standard form parabola, okay? And what we want to do is we want to write it this way, in this format here, so we can see where the shifts are. And the trick is, there's a perfect square trinomial in here. So if you can use what you know about completing the square, you can actually go from here to here pretty easily. So let's do that. We have here y equals x squared minus 2x plus 6. Is this a perfect square trinomial? Okay? The answer is no. The answer is, it would be if you took this right here, negative 2, cut it in half, you get negative 1, square it, you get positive 1. So if this was a positive 1, this would be a perfect square trinomial, but it's not. So we'll do what we've been doing. Make a space here. We'll subtract the 6 from both sides, and now we get y minus 6 on the left side, and we get x squared minus 2x, and now there's a blank here. There's nothing here. Now what did we say we needed here to make a perfect square trinomial? Cut this in half and square it. Half of it is negative 1, square it is positive 1. So we need to put a plus 1 here. Now that's a perfect square trinomial. The only thing is, you can't add 1 to this side of the equation without adding 1 to this side. So we'll also add a plus 1 to this side. Now this becomes y, this becomes minus 5, and this side is the perfect square trinomial, x1 minus, like that. Now the last step, you can see we're almost done, is just to get the k from this side to this side. So we'll just add 5 to both sides, like that. And what we have now is y equals, which is what we wanted. We have the x minus 1, the quantity squared, plus 5, and there it is. That is the same parabola, but instead of being written this way where we can't tell where anything is, we can tell the h is 1. So right away we can go, the h is 1, so we know that we're going to be here. And the k is 5, so 1, 2, 3, 4, 5 is the vertical shift. And you know the vertex is at 1, 5. And then the parabola goes from there. Okay, because trying to graph this, not so obvious. You have to use a table. Here, you can see the vertex is h, k. All right, remember it's x minus h, so if this says minus 1, your h is actually positive 1. So your vertex is actually 1, 5. Positive 1, 5. How about down here? This is a little different. Same problem, but a slightly different type of problem, because we said that you can't do completing the square if there's a number in front of the x squared. Okay, so we have to do something about this. You can't do completing the square unless you have a 1 as the coefficient of x squared. So we're going to do basically a little hack, a little workaround. We want to do the same thing we just did above, but the 2 is blocking us. So how do I get this to become an x squared? I can divide this by 2. But here's the thing. Can I legally do that? No. I can only do that if I do it to every single term on both sides of the equation. So that's what I'm going to do. I'm going to divide everything by 2. Now it balances the equation. Everything, including the y on this side. Divide all that by 2. Now what do I have? Now I have y over 2 equals x squared. This becomes minus 6x plus 11. Okay. Now don't worry about this side. Let's look at this side here. Is this a perfect square trinomial? Divide this by 2, you get negative 3. Square it, you get positive 9. This should be a positive 9, but it's not. So what do? Well, we subtract 11 from this side, and we subtract 11 from this side. So we have y over 2 minus 11, I'm not going to simplify that, equals x squared minus 6x plus blank. It's going to be plus something that we have to figure out. And we already said half of this is negative 3, squared is positive 9. So we need a 9 there. If I'm going to add a 9 to this side, I'd better also add a 9 to this side. Keep the equation balanced. So now where am I? I've got y minus 2. This is going to be negative 2 here. So I have y over 2 rather, minus 2, because that's what I got from here. And now this is a perfect square trinomial of x and 3, right? So x, and it's a minus in between, x minus 3, the quantity squared. So getting close, I can add the 2 to both sides here to make this y over 2 equals this, and then the plus 2 on both sides gives me this. And now the only problem is, what do I do about that? Well, that's y divided by 2. You want to get rid of division by 2. You multiply by 2. But of course, if I multiply this side by 2, the same as here. If you want to divide by 2, you better divide everything. If you're going to multiply by 2, you have to multiply everything. So I have to multiply everything on this side by 2. Now, what is on this side? There's the parentheses, which I'm going to multiply by 2 by putting a 2 there. And I'm also going to multiply this by 2, and that's it. So now what do I have? I have y equals 2 times x minus 3 squared plus 4. And I'm done. What's my h comma k? What's my vertex? My h is 3, my k is 4. So my vertex, this is why it's called vertex form, because you can see the vertex is 3, 4. So if I were to draw a quick sketch of this, 1, 2, 3 on the x, 1, 2, 3, 4 on the y. It's a positive parabola, so it's going up. It looks something like that. Just really quick rough sketch. There's also a 2 here. Now this 2 means that the parabola is actually skinnier than usual. It's a dilation, but we're not talking about that right now. Anyway, that's it. We're done. That's completing the square. See you at the next video.
Check this.